I think many people know that U of L has a very ambitious medical research agenda. The idea is to develop novel treatments that benefit not just patients in the Louisville community, but beyond, in the Commonwealth and beyond. The jewel of this for about 20 years now has been our cardiovascular research program, which year after year has brought international recognition to the university. Many of you will remember our involvement in the pioneering work related to the use of the first artificial implantable heart. Others will remember our innovative work with the development of left ventricular assist devices for patients with advanced heart failure. These are things that gained recognition for the Louisville research community on an international level and have made significant advances for patients with these difficult-to-treat conditions. A cornerstone of our cardiovascular research program over the years is Dr. Roberto Bolli, now more than 20 years into his tenure at the University of Louisville School of Medicine, where he directs our Center for Interventional Molecular Cardiology. Prior to the work that Dr. Bolli has done with the implantation of adult cardiac stem cells, the only option for patients with advanced heart failure would be a surgical option. The idea that has evolved through this research is that it's possible to use minimally invasive techniques to help protect and repair damaged heart muscle in patients with advanced heart failure and not have surgery as the only option. Today, we are thrilled to announce that the National Institutes of Health agree with us that Dr. Bolli's research is notable and well worth supporting. For today, we announce that the National Heart, Lung, and Blood Institute has awarded a $13.8 million extension over a 5-year period to continue to support the work of Dr. Roberto Bolli and his team. They will be using a newly discovered type of adult cardiac stem cells. The idea being this may not just help repair the problem, it may actually lead to a cure. Now, for those of you who have not been involved in trying to obtain a grant from the National Institutes of Health, this is a big deal. As I mentioned, Dr. Roberto Bolli's work goes back over 20 years, but just the application process for this renewal took 2 years. It resulted in a 1,200-page submission to the federal government. And when the results came back after a year of waiting, the answer wasn't just yes, it was yes in capital letters. The NIH said that the work was exceptional and it had the ability to produce a significant translational improvement and result for patients. This is rare praise from the National Institutes of Health and a sign of the quality of the work that they had reviewed. So today it is my absolute pleasure to announce this award, one of the largest NIH awards to be received in the 219-year history of the University of Louisville, and now to welcome to the stage Dr. Roberto Bolli.
Thank you very much, Dr. Postel, for that very kind introduction. This is really a great day to celebrate an award which I think is important for, of course, the Division of Cardiology, but for the University of Louisville at large, and maybe even for the city of Louisville. So first, let me tell you what this is. So this is a program project grant that started back in 2005. It was renewed in 2011. And this is the second renewal. So we now are in the third cycle of this application, which over the 3 renewals will bring to UofL almost $40 million in NIH funding. I could tell you that this is a gargantuan application, but that's a word that my fellows don't understand and that some of you may just listen to and forget. So instead of giving you words, I just show you what it is. This is half of the application, and this is the other half. So As Dr. Postel mentioned, these are 1,200 pages, and it took about 2 years to put together. What's the overall goal of this? The overall goal is to advance the use of adult stem cells to treat heart failure. We are using adult stem cells, not embryonic stem cells. It's called a program project because it consists of 4 separate projects, each of which could be a grant in its own accord. But they're all focused on the same theme. So we have 4 projects which are led by some of my co-investigators. Project 1, led by myself. Project 2, led by Dr. Marcin Wysocinski. Marcin, you want to come here so that you can be recognized. Project 3, led by Dr. Stephen Jones. And Project 4, led by Dr. Aruni Bhatnagar. So the goal of Project 1, very briefly, is that we have discovered a new way of giving stem cells, which I think is going to revolutionize the field. Until now, for the last 20 years, everyone has essentially given one shot of stem cells, expecting them to produce a long-lasting improvement. And we discovered that that's not enough. Probably we are underdosing animals and patients. And so we have tried repeated dosing, and we found a dramatically greater effect with multiple doses as opposed to one dose. It seems like a simple idea, but it has never been done. And so this, we think, is going to change the way clinical trials are going to be done in the future, and we are going to study this in Project 1. Project 2, led by Dr. Wysocinski, will study a new population of cardiac stem cells that he has discovered in the last 3 years, which offers many advantages over the, quote, first generation of cardiac stem cells, which we were studying before, and so he's going to characterize these cells very thoroughly. They're cheaper, they're more consistent, they're easier to produce, and they seem to be more effective than the first generation. Project 3 is led by Dr. Stephen Jones. He's going to look at the effect of stem cells on collagen deposition. That's a very important feature of heart failure. As the heart fails, the heart muscle is replaced by scar, which obviously is very detrimental. And we know that stem cells can decrease this process, and he's going to find out exactly how this happens. And Project 4, led by Dr. Bhatnagar, is going to look at the effect of diabetes on cell therapy. We know that patients who are diabetic don't respond to cell therapy as well as a non-diabetic patient, and so he's going to try to understand why this is and how it can be corrected, because right now almost half of people with heart disease have diabetes, so it's a huge, huge problem. These 4 projects are supported by 4 cores, which are essentially specialized laboratories that provide data and services to the entire program project. So core A is the administrative core that I direct. That's the boring one that takes care of all the paperwork and the administration. Core B is the surgical core, which will do surgery in mice and pigs, because all studies will be done in animals in this PPG. And that's directed by Dr. Iru Guo and Dr. Liang Teng. Please come here to the podium. They are the Debekis of mouse surgery and pig surgery, so if any of you needs any surgery for your pets, these are the people to call, and they will not require Medicare or Medicaid. They do it on a compassionate basis. Core C is the cell culture core, which will prepare the stem cells for all the 4 projects, and that's directed by Dr. Li. Changong, you come here to the podium. And core D is the flow cytometry and pathology core, which is directed by Dr. O'Toole. I don't know if he's here. Tim, come here. Who will do the pathologic examination on the heart sections. So overall, we believe that this project will advance the field of adult cell therapy, which may be really a revolution in heart failure, because heart failure is a huge problem. There are at least 6 million Americans with heart failure. The 5-year survival is worse than lung cancer. It's less than 50%. It's a horrible condition. It is becoming more prevalent as people get older. There are at least 600,000 new cases every year. And we really don't have any therapy to solve the fundamental problem, which is the loss of heart muscle. Once the heart muscle is gone, it's gone. And you can give medicines, as Dr. Postel said, sometimes you can do surgery. But all you're doing is prolonging life by a few months, making patients feel better, but they still will die of heart failure. The problem is not resolved. The reason cell therapy is exciting is because for the first time, we have a way to address the fundamental underlying problem, which is the loss of heart muscle. We can generate new heart muscle to replace the one that died during the heart attack. So our goal eventually is to lay the groundwork for a clinical trial. This is a 5-year project. At the end of these 5 years, we want to go to the FDA and say that, look, we have a new population of cardiac stem cells which we believe is better than the first generation, and we want to test this in humans in a phase 1 clinical trial, and this is the purpose of this application. We did this before, about 10 years ago, with the CPO trial, some of you may remember, which was done here in Louisville, a Jewish hospital, where we were the first in the world to test the c-kit cardiac stem cells in patients with heart failure. That study was published in The Lancet in 2011. It really had a big impact on the field. And those were the first generation cardiac stem cells. So this is kind of the follow-up study on the second generation. And this PPG is important also because it really provides a nice complement to the activities that we have in cardiology on cardiac regeneration. So cardiac regeneration cell therapy is a major focus for the Division of Cardiology. We have many people working on that field, but also we are involved in clinical trials as well. We are proud to be members of a very elite, prestigious group called CCTRN. It is a network funded by the NIH. There are only 7 centers in the country doing phase 1 or phase 2 trials of stem cells in patients. We are now doing a Jewish hospital, 2 trials in patients with ischemic heart failure and with heart failure caused by cancer drug therapy. So the purpose of this PPG is kind of to provide a basic research that then hopefully can be translated into clinical trials, such as the ones we are doing now at Jewish Hospital. So overall, we are, both on the basic side and on the clinical side, we are a leading center in regenerative cardiology in the nation, and I would say in the world as well. Now, what is the significance of this program project for us? Of course, first and foremost, it's a big bolus of money. That's always nice because we obviously needed to continue our research, but it brings more than money. It also brings a dimension of prestige to the University of Louisville. I can assure you these grants are not easy to get. The review process is extremely thorough. Each application is reviewed at 3 levels, initially by a committee of 10 experts, many of whom are our own competitors. So we are being reviewed by our competitors. This committee makes a recommendation, which then goes to a second committee, which then sends its recommendations to the advisory council of the National Heart, Lung, and Blood Institute. So there are 3 levels of review. The review process, as Dr. Postel mentioned, took almost a year. We submitted this in September 2016. I got the final notice of grant award at the end of August. You can imagine my level of anxiety and how many catecholamines I had consumed during those days, waiting for this email from the NIH and making calls and being told, just be patient, it will be next week, just a few more days, and we'll let you know our decision. And finally, the email came, and it was excellent. I don't know exactly what the funding rate is. The NIH will not let you know, but it's certainly less than 20%, maybe 10%. So only 1 in 10, 1 in 5 at the most of these applications are funded. There are not many of them. It's rewarding that the reviewer, as Dr. Postel mentioned, not only decided to fund it, but they gave us really the best possible score. So these applications are graded on a scale of 1 to 5. 1 is the best possible score, and 5 is the worst possible score. So each project, there are 4 projects, as I said, each of them is reviewed by 3 reviewers. Project 1 received 1, 1, and 1. Project 2 received 1, 1, and 1. Project 3 received 1, 1, and 1. Project 4 received 1, 1, and 1. Right. So perfect score across the board. Really doesn't get better than that. And this doesn't happen very often. By the way, we did the same thing 6 years ago in 2010 when we submitted the first renewal. So this was very rewarding for us, and we are very, very happy with that score. For the city of Louisville, this program project, I think, helps, frankly, bring jobs. So somebody did a study where for every dollar a community receives in NIH or other grants, there are $2.5 generated for the local economy. There is a multiplier effect. So many jobs are actually dependent on this PPG. And I think this is good for the community as a whole. The Division of Cardiology, since I came to Louisville in '94, has brought more than $150 million in NIH grants to the university. And so that, I think, has generated a lot of jobs. We have at least 100 people in cardiology working on research, and those people are at least in part supported by NIH grants, and many of those would not have a job if it was not for these NIH grants. So I think this is good for the community. Finally, I want to thank the many, many people who have made this success possible. First, I would like to thank Dr. Postel and Dr. Gansel and Dr. Pierce for their unwavering support and encouragement along the way. Next, my colleagues who are here behind me, who really have done a tremendous job in making this happen. So the important point to remember is that a program project grant is different from any other NIH grant. It's not given really to one person, it's given to a team of people. And if you don't have a team, you can be the greatest scientist in the world, you will never get a program project grant. The program project recognizes a team that works together in a collegial, collaborative way. I'm really lucky to have such incredible collaborators who all work very, very hard. Last summer was particularly tough for all of us, so I canceled my summer vacation. And I used to go to sleep 2 or 3 in the morning for many months, waking the next morning with a headache. It was no fun, but you keep going. And before the deadline, skipping a whole night and so on. These are regular things you do when you submit a grant, but everybody did the same. Everybody worked really, really hard. Many of you guys cancel your vacation and you complain very vociferously about that, but I told you, look, just keep going. Winston Churchill said, if you're going through hell, just keep going, right? Right. So just keep going, and better days are ahead. And they said, look, after the deadline, you can take off as much time as you want, but now you got to work. So people came on weekends and nights, and really was a tremendous effort. And writing a grant of this size is obviously very stressful, but there is one good thing, is that to me was very rewarding, is to see how everybody came together during this time of really intense stress. And it was very heartening and very, very rewarding to see the level of collegiality that we have in cardiology. So a program project is not just a cluster of 4 projects. You can have 4 perfect, scientifically perfect projects. You put them together. Unless there is synergy, you will never get a program project grant. The NIH will tell you, okay, these are great projects, you just send them separately. Why do you put them together? So in order to get a program project, you must convince the NIH that these projects are interdependent, they require true collaboration and true collegiality, and they are synergistic. The whole is greater than the sum of the parts. 1 + 1 + 1 + 1 does not make 4, makes 8. And if you cannot convince the reviewers to that, you're not going to get a PPG, no matter how good the science is. And many, many PPGs fail on that basis. What I'm telling you is that we are a real team here in cardiology. We really work together. Everybody was helping each other last summer. I mean, Aruni needed some mice from Dr. Guo, and Marcin needed some cells from Dr. Lee, and I needed some pigs from Dr. Tang and whatever, and everybody was really going out of their way to help each other to provide all those preliminary data that are really necessary to get this thing to be funded. So I want to thank the whole team, which has been absolutely instrumental. I want to thank the staff persons, Mary Beth Oliver and Nashla Kulenovic, whom I drove crazy for several months writing this application. I want to thank my family, my wife Amy, who's here, and my children who have supported me the whole summer. This was at least 6-8 months of really very hectic work. As I said, I would come home at 2 or 3 in the morning after the kids went to sleep, and I would not see them, and they were very supportive. And finally, most importantly, I want to thank the Lord for giving me the strength and the energy to put this application together. Thank you very much.